G'day chemistry students. In this video, I'm going to be demonstrating how to make a standard solution and also perform a dilution. Now, the purpose of this video is to show you some new glassware that we haven't used before. It's specifically made to measure volumes of specific quantities at really high precision. So I guess the idea here is to show you some of the processes, but we'll look at this in much further detail when we get stuck into it in class. This is going to be in two parts. The first video is going to be about making standard solutions, and the second part of the video is going to be about performing dilutions. And that's going to be done over 2 lessons. So let's get stuck into the first bit. So to start, I'm just going to look at the solution that I'm going to be preparing. So a standard solution is a solution of known concentration. So in red, you can see that I'm going to be preparing a 250 ml solution, and the concentration that I know it will be exactly is 0.1 molar. The solution that I'm making is copper sulfate. I'm making it using a substance called copper sulfate pentahydrate. And what that means is that the substance or the crystal that I'm going to be crushing up is not just made out of copper and sulfate particles, but rather it's copper, sulfate, and then there's also some water mixed into the crystal structure. Now, underneath, I have a bunch of calculations showing how once I know the concentration and the volume, that I can then calculate the number of moles of copper sulfate pentahydrate that I will need to make the solution. Once I know the number of moles, I then also calculate the mass. So the mass that I'm going to be measuring out of copper sulfate pentahydrate is down the bottom there, about 6.11 grams is what I'm going to need. And that's what I'm actually going to be doing in my first step. The copper sulfate particles that I'll be using to prepare my solution today are already quite fine grained. They're pretty much just powder. This is going to be really advantageous when forming a solution because the high surface area of all of those small grains will mean that it won't take very long at all for those particles to dissolve in the water. If you had larger crystals, I would highly recommend using a mortar and pestle to crush up some of the grains, make them significantly smaller, and increase their surface area. The first thing that I'll be doing is placing a weigh boat onto our balance, tearing it so that the mass registers as 0, and then I'll be adding the copper sulfate pentahydrate using a small spatula. Again, I'm aiming to put about 6.11 or 6.12 grams of copper sulfate pentahydrate into the weighing boat. Notice that when I'm making my final additions of copper sulfate, I'm only letting out a small amount at a time into that weigh boat. I really am only trying to add those last few grains to make sure that my mass matches up with the intended mass that we calculated before. I can then place a funnel into the volumetric flask and directly transfer the powder into the flask itself. Generally, you want to put your solid in first. If you start trying to add water during this step, for some solids, you'll end up hydrating the solid, meaning that it's going to end up forming a much clumpier crystal and it's not going to dissolve properly straight away anyway. This clumping can occur in the lower part of the funnel and end up clogging everything up, which can be a little bit problematic. I'm then going to rinse the weigh boat followed by the funnel with distilled water. This is going to ensure that all copper sulfate particles that were weighed are being transferred into the flask. Our next step is to fill the flask up to the graduation mark. In this case, we'll be putting in 250 ml worth of water. At first, I'm going to be pouring water into the volumetric flask through the funnel. I'm going to stop roughly at the point where the water begins to hit the neck. We want to stop nice and early to ensure that any excess liquid that's being poured into the funnel doesn't just shoot up the neck and go past our graduation mark. I'll then move to just squirting in a small amount of water to build up the volume of water in the neck. And for the last part of this addition of water, I'm going to be adding at my distilled water drop by drop using a transfer pipette. At this stage, what I'm aiming for is to have the lower part of the curve of my meniscus lining up exactly where the etch line is on the volumetric flask. Just a note as well, the etch line on that volumetric flask has been put on custom. Each volumetric flask has its etch line at a slightly different point. For this flask in particular, the line marks exactly where the flask fills to 250 mils. Generally, plus or minus 0.1 of a mil is the margin of error there. And then inverting the volumetric flask, making sure that my hand is covering the cap that's been placed on top, holding it nice and firm, inverting and shaking the content that is inside, attempting to dissolve the remaining solid copper sulfate that is present. Once dissolved, I noticed that the position of the meniscus has dropped slightly. This is because as we have dissolved some of that copper sulfate pentahydrate, the volume of the entire mixture has changed as a result. Generally speaking, when this happens, the volume will lower. So what I'm doing is just adding a few extra drops of distilled water to raise my meniscus back up to the point at where it should be. I'm then going to just quickly invert and mix again to ensure uniform concentration for the entire solution. In the next step, I'm going to be performing a 25% dilution, meaning that I'm going to be taking 25 mils of the standard solution that I have there and placing it into a 100 ml volumetric flask. From there, I can fill up the remaining volume that's in that flask with water and invert to ensure that concentration is even throughout the entire solution. What this will mean is that the concentration of the new solution will be 25% of the original solution. For this step, I will need a 25 ml volumetric pipette, which is designed to draw up a very precise and exact amount of liquid. For this one, it has a bulb big enough to hold 25 mils of liquid. I'll be attaching the pipette to the pipette filler. Notice that my hands are really close to each other and are on the joining end of the filler and the pipette itself. My hands are in this position for safety reasons. Potentially you can snap the very thin parts of the pipette itself if the wrong angle and amount of pressure is applied to it. So by placing your hands really closely, you reduce the risk of the pipette snapping. It's a little bit difficult to see, but on the pipette filler, there is a dial that you can rotate and it pulls up liquid into the pipette just like a straw. Now, what I'm going to be doing first is rinsing this volumetric pipette in case there are any contaminants in there. Now, to do that, what I will need to do is draw up a small amount of liquid, remove the pipette as well as the pipette filler, ensuring that I catch the liquid that is inside with my thumb. I'm then going to lift the pipette and put it on its side, ensuring that my thumb stays on the top. By slightly releasing my thumb, I can begin to move some of that liquid into the bulb. I'm then going to rotate this constantly, ensuring that all parts of the glass are able to make contact with the copper sulfate solution. This is going to pick up any contaminant particles, and I'm going to be releasing that into a waste beaker momentarily. I'm then going to tilt the pipette, trying to get some of the liquid into the top part of the pipette. You'll notice that I catch the liquid with my thumb before it exits out the top. Generally speaking, we don't want any liquid coming out the top of the pipette, as that can get into the pipette filler and cause damage. So once I've caught it, I can then turn it back the right way up, making sure that the end of the pipette is in my waste beaker, and release my thumb to release that liquid. Generally, we would complete this rinsing step in triplicate, but for the sake of an efficient video, I'm not going to be doing that today. We can then go and actually fill the pipette now that it is rinsed. I'm going to put it back into the first solution, attach my pipette filler, and draw up the liquid into the bulb, and then past the graduation mark, which is on the top end of the pipette. I'm then going to remove the pipette filler and hold it with my thumb, creating a seal just like you can at the top of a straw, and hold the liquid in place. I'm then going to move the pipette over to my waste beaker and begin to release some of the excess liquid which is sitting above the graduation mark. When I let it out, I'm going to stop and reseal the pipette with my thumb again once the level of the liquid is at exactly the same spot as a graduation mark. Similarly to what you can do with a volumetric flask, you can try and get the bottom part of the meniscus to line up with that line. Once I've measured out exactly 25 mils of copper sulfate solution, I can transfer that into the 100 ml volumetric flask. Similar to when we were making a standard solution, the last thing that we then need to do is actually fill the flask to its etched mark. So that will require me to first pour some liquid in. I'm going to stop at about where the neck begins to curve in, and then for the remainder, just transfer the last part of distilled water using a transfer pipette, adding 1 drop at a time, ensuring that the meniscus, or the lower part of the meniscus in particular, lines up with the etched line on this 100 ml volumetric flask. The last thing to do is cap the flask and invert a few times to ensure that the concentration of the solution is even throughout the flask. And there you go. In this video, you've seen some steps to prepare a standard solution from mass, as well as then be able to take a volume out of a solution and transfer into a new flask using a volumetric pipette to complete a full dilution. In the coming videos, we'll look at how to do dilution calculations specifically and some of the theory behind that, looking at mole and concentration concepts that we've already begun to touch on in this module. But until then, have a good one.